All right, guys, here we are, Chapter 2 of the NASM curriculum. Welcome back to the Axiom Fitness Academy, and I'm excited to jump into part of my favorite of the Academy, and that is really the science, the background, all the things that make the body work, because it's one of those things that, as we talked about in Chapter 1, it's not only going to help differentiate you amongst many other trainers who just don't understand in depth the systems of the human body, but it's also something that's just going to make your confidence as a fitness professional, a trainer, go through the roof. Now, I don't expect you to retain every ounce of what we go through and talk about. Again, I'm going to do two things. I'm going to try to make sure I introduce you to some additional concepts and really break down some of the systems, because I think there's definitely some value in that. But I'm also going to really try to point out, okay, don't stress too much about memorizing this entire process, because I do want you guys to, do well on the exam and get on to actually training people. So don't get too caught up, because if you think about it, those like myself and others who've actually gone through exercise science spent semesters and semesters on just individual concepts within this Chapter 2. All right, so don't stress too much. This is usually where people get a little overwhelmed, but hey, that's why you're not doing it on your own, and that's why we're going through it here together. So Chapter 2, basic exercise science, although maybe I should say like scary advanced exercise science, because there's a lot happening here. All right, so our goal here in this chapter is really going to be to break down a couple of the different systems of the human body. The nervous system, right? So we've talked a little bit about that communication system, our neuromuscular system of the body, sending signals to the body and how that functions. Our skeletal system, right? Just the bones, the structure that makes up the human body. Our muscular system, so all the muscles that allow us to actually create movement that attach to that skeletal system. And then also the endocrine system, which we're not going to spend as much time on the endocrine as we do the other three systems, not because it's not important, it's actually massively important, but for the scope of this course, we just don't have enough time, right? So the endocrine system, the hormones, because it really is the master regulator of the human body and so many of our processes. So we'll get a little basic understanding and hopefully direct you in the right ways if you want to dive deeper down that path. So. And we're going to really now, after breaking down these systems individually, start to try to tie it all together, because that's really where things happen, and that's where either the magic is or where things break down, is when especially the nervous system, the skeletal system, and the muscular system don't play well together, or something is off, as the synergy of those three systems is essential when it comes to creating good fluid movement and helping our clients get results. So diving right into here, the human movement system. So this would be one I could flash up on the screen for you guys again too. An easy definition one for your exams to get right. The human movement system is accomplished through the functional integration of the three systems that we already highlighted: the nervous, the skeletal, and the muscular. And that's just what to remember. The human movement system is the combination of those three and how they function together, really. So these systems work in concert to produce motion, which, hey, there's a word you're going to continue to see, kinetic, which just refers to motion and forces, or human movement. All right, so human movement system, pretty easy term for you guys to remember, but you'll probably see that abbreviated as HMS for human movement system throughout the text. So this is what we're talking about. We're talking about the integration of those three systems and how they function together. All right, so going back to that word that we just pointed out, kinetic chain. So kinetic referring to forces, chain referring to how things translate upward and downward and outward and inward through the body. All right, so the kinetic chain, refers to a system that is linked together or connected, just like the human body is, right? So when we're out and about in the world, where do all forces in the world come from? And just kind of think about that for a second. So if I'm not touching anything else, right, I'm walking around, where do forces come from? Right? Well, I'm only connected to one thing. My feet are connected to the ground. So it's all about ground reaction force, especially as we're talking about activities of daily life and moving throughout the world, that we're going to have force generated from our core. We send that force down through the legs. We push off the earth. The earth is much larger than us, so when the earth pushes back, we move in different directions. So that's going to be important when we start to think about static postural assessments as well as movement assessments, is thinking about, okay, cool, well, let's start from the ground. And that's exactly what we'll do. We'll start from the ground and start to work our way up, right? So that's kind of like a general basic introduction to the kinetic chain. But it's all about how these components work together Because if we have, as we'll talk about with the overhead squat and single leg squat and push-pull assessments, if we have some things somewhere upward or downward in our chain that aren't moving right, whether we were born a certain way and our skeletal system is just not built the same as others, or we have an injury and we've got some adhesions in the muscles, or neuromuscularly we're not communicating appropriately, all those things can alter how we move and alter how forces translate throughout the rest of the body, all right? If one component of that chain, like we just talked about, is not working properly, it definitely can and will affect other areas. Doesn't mean we're going to have injuries right away, but we're going to have inefficient movement. So us as coaches and fitness professionals, we're going to try to improve that. So just like we talked about, right? We've got forces that come. You guys can see there's a small skeletal, figure here. Either way, forces come from the ground, especially as we're walking, all right? And here, you guys will continue to break down, and you guys will see in a separate video that talks specifically about the stability mobility chain in the body. But our foot is supposed to be a place of stability, right? It's like our contact point with the earth. All right, so for those who will find maybe they've got collapsed arches or instability in that foot, that can cause issues up the kinetic chain. So again, there's our first joint. And the nice thing is the body operates in this pretty consistent stability, mobility pattern throughout the body. We have one area we want to be stable, the next area we want to be mobile. Next area should be stable, next area mobile. And that allows us to do a lot of movements fluidly. So again, when one area that's supposed to be stable isn't, or an area that's supposed to be mobile isn't, it can cause problems. So the foot should be that place of stability, that first one, our contact point. Our next joint up from there would be the ankle joint, right? So we've got the foot, right above that would be the ankle. So generally, we want a lot of mobility in the ankle. We want dorsiflexion, plantar flexion. These are words that you guys will hear more and more, so I'm going to start using them now, right? Pulling the toes up, dorsiflexion, plantar flexion. We want to have eversion, inversion, to be able to move. So when we don't have that motion, which you'll find a lot of people don't, and that's the source of a lot of people's issues when it comes to squatting and lower body movements, is maybe a lack of ankle dorsiflexion. Again, causes issues further up. So from there, we move up to the knee. So the knee, we really want to be a stable joint. It doesn't mean we don't want the knee to actually, flex and extend, but if you think about it, we don't want tons of lateral movement in that knee. We want it to be a stable joint. If we move further up from there, the next area of the body is going to be the hips. So sometimes we'll also call that the LPHC, the lumbo-pelvic hip complex. But we want those hips, to be relatively mobile. If you think about the hips and also the shoulders, they're a ball and socket joint, right? So they really should have the most range of motion almost of any joint in the human body. So many of us do have some hip issues. We'll start talking further about, being seated throughout the day, having tight hip flexors, glutes not firing. There's all these things that come from that. But just keep in mind for right now, we want hip mobility. We want lots of good fluid motion there. So we're going to try to encourage that through what we do as coaches. The next area up from there is going to be that lumbar spine, the low back. So we talked about it in the first chapter. Some of you guys raised your hands, probably too, on how many of you have had low back pain. So that area of the body, again, it's an alternating pattern. We were at the hips, we want mobility. So if we move up to that lumbar spine, we want stability. So it doesn't mean it doesn't have the capacity for movement, but when I'm doing functional activities, when I'm deadlifting, when I'm rowing, I'm pressing, I don't want a lot of movement in that low back, right? It's not a good thing. It's an area of the body that's not super strong, so we don't want to place a lot of stress there. So we want stability there. Next up from our lumbar spine will be our thoracic spine. That's our mid-back. So this would be an area, so we went from stability in the lumbar spine. Next up, thoracic, would be mobility. If we really look at and break down the spine, right, we have the most number of thoracic vertebrae. So if you think about that, that's the most number of joints, which theoretically means we should have the most ability for motion. But because of daily life in the world that we live in now, many of us have a little bit of this, what we'll call kyphosis in that upper body, or a slight rounding forward in that thoracic spine. If you think about it, it makes sense, right? We're on our phones, we're at our desks, we're seated, all of it kind of gives us this rounded posture. So when we go to start do other movements, not a lot of our clients might have a lot of movement in that thoracic spine. So there's some real easy movements and assessments that we can do to kind of see where they're at with that. And then also some simple strategies we can do to try to improve that range of motion, that mobility in the thoracic spine. So next up beyond that is actually going to be your shoulder blade, right? So we have the thoracic spine, In there, next joint or area of the body is our scapula, our shoulder blade. So that scapula, we had mobility that we want in the thoracic spine. So the shoulder blade and the scapula, we're going to want stability there. Now, it doesn't mean that shoulder blade can't move, because it actually does a lot of movements, right? It does elevation, like when you're doing shrugs. It does depression, sliding down the back of the ribs. It also does protraction, let's say when I'm doing a chest fly, where the shoulder blades come around the ribs. It retracts and comes back together when I'm doing pulling exercises. And when I'm doing things like lat pull downs and pull-ups, it also upwardly and downwardly rotates. So it's crazy. It's got all kinds of movements and really only one attachment point aside from muscles. So there's a lot of capacity for movement, but during a lot of exercises, we want stability there, right? If those lats and those shoulders and the scapula can hold themselves in place, then it allows us to transfer forces better, all right? And then really as we start to go through the arm, it's pretty much the same as the leg. The shoulder, this glenohumeral joint, is much like your hips. We wanted mobility in the hips. We want mobility in that ball and socket joint in the shoulder. Elbow, just like the knees, right? We want stability in that elbow. Wrist, just like the ankle. Mobility in the wrist. And then hands, just like our feet. We just don't walk on them. We want stability in those hands. So that'll start to make sense when we start breaking down things like wrist pain from doing push-ups, because a lack of mobility and maybe even a lack of strength and stability in the hands. So I know I just threw a lot at you guys with that stability mobility chain. That's why, again, you'll see an additional video just breaking down that. But it's a really important concept, and one that can make a lot of light bulbs go off when it comes to working with your clients, because you'll start to understand things like knee injuries, back injuries. You know, oftentimes we think wherever we're having pain, like that's just the source of what caused it. But sometimes for many people, it can be caused by a lot of other things that were happening throughout our life that led to this injury. And oftentimes it could be stress that's coming up throughout our kinetic chain in a slightly different or less advantageous way because of something else that's going on in that chain. All right, so kinetic chain, really important concept for you guys to get and understand. Getting into and breaking down the nervous system, right? So the nervous system, this is our text message system of the body, provides a communication network within the body, all right? So we've got essentially two sections of this. We have our central nervous system and our peripheral nervous system. And the easiest way to think about it, central nervous system is going to be the center of our body, or like really the spinal cord and our brain, all right? So that general center of the body. Spinal cord and brain, that's going to be the central nervous system. Peripheral nervous system, all the nerves that communicate with the central nervous system, all those nerves that go out throughout the rest of our body. All right, so again, just understanding the difference between the two for right now is the most important piece. We don't really get into breaking down all of the different like peripheral and cranial nerves and everything else from a higher level standpoint. But within that nervous system, all right, it's all about gathering and getting information. Our body is taking in information all the time. Visually, you guys are taking in information right now. You're seeing me, you're seeing what's on the screen, right? You're getting that aspect. You know, you're getting the auditory information that's coming in. You're getting a sense of like the temperature in the room that you're in right now, the pressure of your feet on the ground. You know, internally, your body's getting a lot of information as well. So it's a beautiful, amazing communication system and network. But allows us to get this, process it, understand what it means, interpret it, and then do something with it, right? So sometimes that means moving. Sometimes that means doing nothing. Sometimes it's just taking in the information around us. It's three primary functions of our nervous system. First one is sensory. We just talked about that. Sensory, taking in all the senses, getting information. The next is going to be integrative, and this is kind of like deciphering the information. So once the information has been brought in, goes to that central nervous system, we have an integration and understanding of what's going on, and then our body has some sort of action or reaction, and that's going to be the motor aspect. That would be like me causing or telling my body to do a movement. All right, so those are our three separate functions of the nervous system. All right, so breaking down the nervous system a little bit more, proprioception. So what is proprioception? Another great one that's kind of a buzzword that is an important term for you guys to know. The body's ability to sense the relative position of adjacent parts of the body. If you and I were just talking in conversation, I might say that's like body awareness, right? So understanding where my body is in space. Like when I close my eyes, I'm still getting information from my feet, from my spinal cord, to where I can kind of picture where I'm at and I can understand that. All right, so proprioception, you're going to see and hear that word a lot. And we can train this. We talked about that, right? In that stability phase, we can train proprioception. What we're trying to do here, by training these systems, it's going to do things like hopefully potentially improve balance for all ages. You'll find even your younger clients never train balance, so getting them on a single leg is a really valuable thing to do on a regular basis, just to get that system firing regularly. Coordination and posture, right? So these proprioceptive systems are important and play a role in all of that. And they enable the body to adapt to its surroundings without consciously thinking about movement. So if you think about it, with your older clientele, this is going to be so valuable, because there's a lot of systems, there's a couple systems that break down as we age. We not only have our muscle atrophy, so the muscular system starts to break down. So by strength training and working out and eating right, we can maintain the muscular system better. But neuromuscularly, we have degradation. We have some, potential death of neurons in the brain. We also have, if we're not sending signals to our muscles to do something, those signals aren't always sent as strongly, right? So if they're going to fall and they're not used to having to catch themselves or put their foot down like that, like it's not going to happen as quickly. And then, also the sensory side of it. They're not used to being on one foot. So when the foot slips and they're in the air, their body's not used to it, right? So that inner ear organ that may break down as we age, it's not being trained, right? So our body's not going to react and adapt as quickly. But by doing so, we can at least lessen the likelihood that those things happen and improve the ability to adjust. So that's kind of what you're seeing a little bit here in the image. It's just our body getting information and doing something with it. And these things are reflexive, so you're not necessarily thinking about it. So like right now, if you guys are, if you're in a space where you don't feel, embarrassed to get up on one foot and just stand there, get up on that one foot, still be watching the video, right? So you're paying attention to what's going on up here. You're not looking at the ground, and just feel those little muscles fire in the ankle and the hip. You're not thinking about doing that. That's natural reaction. Your body's trying to maintain balance. So we can improve that process, but only by doing it. All right? And I wouldn't really worry too much. Don't stress about having to break down the anatomy of a neuron. Again, we aren't back in anatomy class. But it's just a general understanding that the neural system in our body, it's an actual system of electrical conduction, right? We actually have small electrical signals that are being sent. And based upon the structure of a neuron, they can happen rapidly, millions of times, right? Millions of times, a second or whatever the rate might be, but it's super fast. And from a physical standpoint, you actually have a separation. So in between our neurons, there's space. But because of the conduction of that electricity, it allows us to kind of skip some of the distance, and that signal can fire that much faster. All right, so you guys will see on there when you break it down into the book, understanding the nucleus, the cell body, the myelin sheath, which actually allows us to send that signal faster because it skips some of those gaps in between. But just knowing there is a physical space in between, it is an electrical signal that's being sent. And we can improve that pathway. Just by doing it, we can improve the pathway, which is super valuable at all ages, right? It means we can get better at movements, exercises, strength, or just general daily function. And then getting into the peripheral nervous system. So we talked about the central nervous system a little bit, right? It's more of automatic reaction, integrating information, deciphering it, sending out a reaction. And things like reflexes, that's a central nervous system response. I'm not thinking about doing it. Peripheral nervous system is a little bit different, all right? So it's subdivided into two categories, the somatic nervous system and the autonomic nervous system. All right, so somatic nervous system, this is going to be nerves that serve outer areas of the body and the skeletal muscle, and is largely responsible for voluntary control. So easiest thing to think about here, somatic nervous system, these are the moves and the contractions and signals being sent that we think about doing. It's more conscious. So movement is going to be, really controlled by the somatic nervous system, like your skeletal muscle. The autonomic nervous system, easy thing to remember, is automatic, right? So those things you don't want to think about doing, like I don't want to think about breathing. I want that to happen naturally. Same thing with digestion. So more of these things that don't need to be on mental, but we want them to be on autopilot. This is the more of the autonomic nervous system, all right? And then the autonomic nervous system is further divided into sympathetic and parasympathetic, which there's a lot of interesting stuff. We could spend a ton of time here. I'm not going to. I'm going to talk a little bit more just for your general knowledge and understanding, not because it's so important for the exam. But if you think about it, so we have, many of you guys are familiar with like the fight or flight response, right? That would be part of this, autonomic nervous system. So we have the sympathetic, parasympathetic. The sympathetic nervous system, that's going to be that fight or flight, right? If you've ever been in a car wreck, or you've been close to being in a car wreck, or hopefully, hopefully you haven't been chased by a bear, but hey, guess what? I'm walking through the woods, I see this bear, what's going to happen? Pow! All of a sudden, I'm stricken stricken with the ability to do a lot of things. And this is a survival mechanism for your body. So right away, you guys can think about that heart pumping feeling. So some cool things happen inside the body when the sympathetic nervous system is activated. So first off, it's mobilizing our body for activity, whether it's to run the heck away or to like stay and fight, right? Fight or flight. Increase in heart rate, boom, rapidly, right? So my body says, boom, I need to get blood flow to the muscles as fast as I can, so my heart rate's gonna increase quickly. Also, you're gonna feel it, that thud. You have an increase or a release of adrenaline, that epinephrine, norepinephrine in the system. Now what that does is that not only allows your heart to beat faster, but harder. All right, so it increases the contractility, which means I'm now pumping more blood, not just in my rapid rate, but actually more in every beat out to the body. We also have a massive redistribution of blood, right? So all of a sudden, all that blood that was feeding my organs for more of the things that happen when I'm at rest, that goes whoosh. I have vasodilation, vasoconstriction in my blood vessels to get all the blood to the areas of my body that need it. So for me, I'm super fascinated with this stuff about the human body because it's amazing. It may not be as much of a test question for you guys, but just an indication of how quickly your body can change these things, get blood where it needs to go, and allow you to do activity. Right away you kick up carbohydrate metabolism, and your body is ready to do what it needs to. So very, very interesting. That's going to be your sympathetic, and then you have your parasympathetic, right? Not only just cute yoga girl here, but this is going to be all right, when I'm chilling in my desk throughout the day, my parasympathetic system is going to be more predominant here. And this is going to be where your body, it pulls some of that blood away from the skeletal muscle. It puts some more blood to your digestive system, making sure you're getting enough blood flow there for that to happen, right? Making sure plenty of blood flow to the brain, whatever it is. And all those other systems that happen here, they downregulate. So your body's in constant sync between the two at all times. So we're talking about an extreme situation here, but the interesting thing is, at a lower level, exercise is a stressor, right? So even just when I start to exercise, these things happen. They may not happen at the same level as if I'm getting chased by a bear, but I do have the increase in heart rate, contractility, mobilization of glucose for energy. So it's a stressor of the body. And that's an important thing to think about and remember, because exercise is a stress, right? And too much stress can be a bad thing. So we want to make sure that the level and the demands that we're placing on people is appropriate. All right, so just some cool additional information for you guys about the the sympathetic and the parasympathetic nervous system. We could spend a whole nother hour talking about those, but we don't have that kind of time. I got to get you guys into the exercise side of things. All right, and then the autonomic nervous system, like we talked about, this is going to be the stuff you don't want to think about having to happen. Digestion, heartbeat, breathing rates, all that stuff. So that part of our nervous system is on autopilot, for the most part. And then generally sensory receptors. So primarily in the course, we're going to be talking about mechanoreceptors, right? Those are the ones that respond to mechanical changes in the amount of force, changes in the length of the muscle, pressure, that kind of stuff. But we have plenty of different types of receptors in the body. Nociceptors for pain. We also have chemoreceptors that respond to different chemical responses inside the body, and then photoreceptors, as you guys can think about, for light. So primarily in the course, going to continue to talk just about mechanoreceptors, but important to know that there is a lot of information coming into the body. So diving in a little bit deeper to understand the specific mechanoreceptors that are most important to us, not only when understanding movement, but especially even when we get into talking about flexibility, and our body's ability to get in positions and tension. There's just a lot going on. Our body's constantly getting in and taking in and receiving this information, whether we're thinking about it or not. So we'll talk about more extreme situations, but it's always happening throughout our body and all the different muscles. So a couple of the most important ones: muscle spindles, Golgi tendon organs. I can guarantee, again, circle those suckers with a red line and stars and everything else, because you're going to have plenty of questions built around muscle spindles and Golgi tendon organs on the NASM exam. And they're also just really valuable structures for us to understand and know. So the muscle spindles, these are going to be sensitive to changes in length of a muscle and how fast that length changes. We're going to talk specifically, we'll give you guys some images as well. And then Golgi tendon organs, and actually before we go there, muscle spindles, so they're also going to live in the muscle, right? Because I want to give you guys some words and mnemonic devices, not to confuse the two, because that's easy to do. Muscle spindle, it's going to live in the belly of that muscle. So again, it responds to not only the change in length, but how fast and how rapid it happens. So that's good though, right? We've got these muscle spindles throughout our entire body, like I'm talking about the bicep right now because it's easy to visualize, but they give us information like where's my body at relative to my joints and positions. So that's a good thing. Golgi tendon organs, just like it sounds, they're going to live in the tendon of that muscle or muscles in our body, right? So we're talking about the bicep, we're talking about that bicep tendon. And they're going to be more sensitive and responsive to changes in tension. So not just the change in length, but the tension, right? If I have a huge change, a huge additional amount of force that goes into that tendon, then my body's going to have a response. So these are both informational as well as protective mechanisms of the human body. And then overall, we also just have joint receptors that give us information about what's happening inside of a joint, respond to pressure, acceleration, and deceleration of that joint. So again, all these internal mechanisms to give us information so we can improve movement. All right, so the muscle spindle. So we've got a couple examples for you guys on here. So when the muscle spindle is activated, it's activated when we have a rapid change in length, right? So we're talking about the bicep here. I've got a rapid change in length of that bicep. So what happens is those little fibers that sit in the belly of the muscle, they send information to my central nervous system, right? They activate, that muscle spindle sends a signal to my central nervous system saying, hey, this muscle length is changing pretty rapidly. And what my central nervous system does is it automatically sends a signal back to tell that same muscle to contract, right? So if my bicep is lengthening really quickly, boom, it sends a signal to try to say, all right, slow it down. So if you think about it from like a protective standpoint, that makes sense. For those of you who are not from the Midwest, you might not get water skiing or anything like that, but I can think about it from like a water skiing standpoint. If there's slack in that rope and I'm in the water and all of a sudden that rope is pulled and my arms extend out like this, my body doesn't want me to tear a bicep, so it's gonna sense that rapid change in length and it's gonna force me to fire that up so I don't reach that end range of motion in that joint, all right? Couple other good examples for you guys too, just about how our body functions with it, because it's not all about preventing injury. If we talk about kettlebell swings, so many of you guys are familiar with kettlebell swings, right? It's a nice, rapid, powerful, explosive, hip-driven movement. And in this image you guys see here in the muscle spindle, so we've got the multifidi in our lower back up and throughout those spinous processes in the mid-back that create some tension posturally. So when I go downward in that eccentric phase of the kettlebell swing, I have a short but a rapid stretch. Just like in the bicep we talked about, I have a rapid stretch of those muscle fibers. So the muscle spindle gets activated in those muscle fibers, and what does it do? It causes contraction in the same muscles. So that rapid eccentric to concentric loading gives us a little bit of an additional quick contraction of those same muscles, which is great. Kettlebell swings are an amazing exercise for strengthening the spine because of that. But just keep in mind, that's also one reason why they are so challenging. We want to make sure people have the right type of strength, position, and posture to be able to do them. Another good example that might relate to, if you guys have ever had that little knee tap test at the doctor, right? They hit that patellar tendon with a small mallet. Well, the reason they're doing that is they're testing your central nervous system. And if your central nervous system is functioning appropriately, we should have a small leg kick out. And that's because as we hit that patellar tendon, what it does is it causes a real short but rapid lengthening in the quadricep muscle. And again, if my central nervous system is functioning well, I should have the muscle spindles in that quad send a signal to my central nervous system back to my quads to contract and cause that small leg kick. All right, so that's kind of your simple, brief explanation of muscle spindles. Spend some additional time Googling that, reading about it in the book if you need to, because it's one I definitely want to make sure that you understand for our NASM materials and just overall function as a fit pro and a trainer. Next up is the Golgi tendon organ, right? So in the Golgi tendon organ, just like it sounds, that's going to exist in the tendon. So it's going to sense a huge amount of force. So this is a good image right here. Let's say this is going to be someone's bicep. And let's say they're trying to lift up a car, right? For whatever reason, they might need to lift up a car. Maybe there's somebody under it, all right? So in that position, we have this massive amount of additional force that gets sent into the bicep tendon. And your body, if it's going to be enough that you may rupture your bicep or the tendon, your body's like, okay, this is a lot of force. So what does it do? It does the opposite of the muscle spindle. It actually sends a signal back to that muscle to relax. Or really what it does is it inhibits muscle contraction. All right, so if I have activation of the muscle spindle, it causes contraction of that muscle. If I have activation of the GTO, it causes relaxation of that muscle. That's the easiest thing you need to keep in mind. And as we get to flexibility, we'll talk about like these systems are always kind of at play a little bit as well in less strenuous, less stressful positions and scenarios than we're talking about. But that can help dictate, how much range of motion our body's given us. And we can take advantage of some of those systems too with things like plyometric training and, active and dynamic stretches. All right, so next up, the skeletal system, right? This is the framework of the human body. So there's a couple of functions here. For one, it is a lever system, right? So that's one purpose of the skeletal system. It allows us to have muscles that attach to the skeleton to create movement. It's also protective. Things like the skull, the rib cage, shoulder blades, they protect some of our internal organs, these soft, sensitive parts of our body that we want to maintain. And the other thing is we also have production of certain things like red blood cells inside of the actual bone marrow of those bones. So just keep in mind the skeletal system is very much alive. Bones are alive. They are always breaking down or always building up. They're never just stagnant. They're definitely a living mechanism and an important piece. And small changes in that skeletal system can have a big impact. Not only for someone, like if we've got some asymmetry, like one leg's longer than the other, or they're built a little different, that of course can change how we move. But even small things like someone's lever length, like someone if they've got longer femurs relative to their body than someone else, it changes the levers of the body. And that can be advantageous or it can be disadvantageous when it comes to certain movements and things like that. So definitely another big variable here as well. Resting ground for our muscles, but it's also a lot more than that too. So, and for you guys, I'm not going to go through and spend the time to break down and talk about each individual specific bone in the human body, but I definitely think like what you guys see on here, you should know, not only for general anatomy to know like where your humerus is, your radial ulnar joint, so we understand those structures that muscles need to attach to, but also for your guys' exam. So I would, if I were you, I would jump on Google, I would choose a blank skeleton chart, and I'm sure you're gonna find some blank charts that have skeletons, and practice filling that in, and then go back and study the ones that you don't remember or you can't remember. That's a great way of studying if you're a visual person like me. So like I talked about, bones always building up or always breaking down. We have osteoblasts, osteoclasts. That's one reason why if you're an astronaut and you're out in space, we've got to actually stress those bones with actual training, right? Since there's no gravity, in order to make sure we're stimulating bone growth and it's not breaking down. So this is one of the reasons why strength training, weight-bearing exercise is good for all ages, maybe even more so for our postmenopausal women, 40, 50s and above. So definitely an important piece here, making sure we maintain that bone mineral density at all ages and for all populations. All right, so what about types of bones? All right, so we've got many different types of bones in the body. This is one I wouldn't get too caught up on. I wouldn't get worried about like memorizing everything of it, but one thing to keep in mind, form follows function. All right, form follows function. So when it comes to understanding anatomy, understanding skeletal anatomy, our bodies were built to like essentially take stress and loads in certain directions. So here with this long bone, it makes sense that this bone is going to be able to take a lot of force up and down, right? So this could be like the humerus or the femur. Our body's built to take a lot of force in that direction, this vertical. But horizontally, right, I'm not going to have to hit with a lot of force to break that bone. So form follows function. And this is, again, I can have muscles, long muscles attached from there. I wouldn't stress too much about the anatomy of the bone, the epiphysis, diaphysis, growth plates, all that stuff. Just general understanding with that. And we'll talk later, as you guys might be thinking, well, what about training with kids and growth plates? We'll get there with our special populations, and we'll talk a little bit about why a lot of what you have heard may not be exactly accurate, and why strength training at any age, if done right, can be very beneficial. All right? Types of bones, we got short bones, like within the hand. Again, form follows function. Our body has adapted that way for a reason, allow us to give certain movement. We also have flat bones. These are thin, maybe more protective, like your shoulder blade or your scapula is a great one. It also allows for a lot of different areas for us to attach muscles. So as you can see on here with the anatomy image, we got all kinds of muscles attaching on here, rotator cuff muscles, tricep muscles. So there's a lot of attachment points, and it's also protective as well. Irregular, like all the bones of the spine, so unique shape and function. So general understanding, more important that you just know the function of the skeleton itself. I'm not so worried about the specific bone types. All right, but this is definitely an important slide here. The vertebral column, right? The natural curvature of the spine that we see. Right, so we have a sacrum, which essentially has 5 fused vertebrae that down here at the bottom. And then we're going to have a slight curvature coming into our lumbar spine, which we have L1 through L5. We have 5 lumbar vertebrae. And then thoracic, T1 through T12. So there's 12 thoracic vertebrae. We talked about that, and that's an area where we should have a lot of range of motion and may not. And then we have that curvature back forward again into our cervical, 7 cervical vertebrae. All right, so when it comes to understanding posture and movement, then really what we're looking for here, everyone's going to have a natural curvature, everyone's going to be a little different, but we're looking for gross exaggerations. Do we see like a pretty gross exaggeration in that thoracic into cervical vertebra that's giving us an idea that, hey, you know what, this is this kyphotic posture that I'm seeing, or a big change in that lumbar spine for something that we might consider to be lordosis. Those are the big things we're looking at. So understanding of those, the number of the different vertebrae I think is important because again, it gives you a sense of like how much movement should we have there. All right, but very delicate part of the human body. And then joints in general, right? This is obviously where one bone articulates with one another, and not all joints are the exact same. We've got rolling joints, sliding joints, and spinning joints. And each of those give us certain abilities and capacities. So I wouldn't stress too much about this, but just keep in mind joint motion is referred to arthrokinematics, and the joints above and below any other joint, like we talked about, stability, mobility, those do play definitely a role in the forces that we get in the other joints, right? For example, the knee is a great one. The low back is a great one as well, where many times, unless there was like a contact injury or a stress right there, it could be the pain and injury that we have there could have been caused by something below or above that kinetic chain. All right, and then joint connective tissue, right? So here, when we're talking about connecting muscle to bone versus joint to joint, all right, so muscle to bone is going to be a tendon, joint to joint is going to be a ligament. So just keep those in mind, easy ones to get confused sometimes. Ligaments connect bone to bone. This is a great example here, like at the knee. We've got ligament on the outside and the inside of the knee that's going to help give us some structure, right? We wouldn't want to be so rigid, like we want to be able to move a little bit. We want to have a little additional structure that joint's not going to move and go out of place. So unfortunately, tendons and ligaments don't get great vascularity and blood flow. So oftentimes, tearing a ligament or a tendon or something else can really be a challenging injury to come back from, because unlike bones and muscles, there's maybe not as much vascularity and blood flow to help drive that recovery and that healing process as well. All right. And weight-bearing exercise, we already talked about it. That's going to help build more dense, more dense bones by stimulating, the production of that bone mineral density. All right. So, and now moving on to the muscular system. You're like, all right, cool. We got past the neuromuscular system. We got past the skeletal system. Now we're on to the ones I'm concerned about, or probably the ones that your clients might be more concerned about, right? The muscles, the muscular system. But the other pieces are important because they impact our ability to use and fire and strengthen the right muscles. And so we want to have an understanding of all of those. So again, this allows us to generate internal tension and cause movement throughout the body. And they're also helpful in regulating body temperature, right? Because that's going to be a thermoregulatory impact. And there's a protective mechanism too, right? If we have muscle that can protect, our body and our organs. But for the most part, we're talking about movement. And this is really where a lot of students end up getting challenged and really struggling as the course goes on, because there's just a strong memorization component here. Unless you're, beneficial enough and fortunate enough to actually have a cadaver lab that you're going to go do and be a part of, which many of you won't. Even those in exercise, science programs don't often. I was fortunate to do so, and it definitely solidified a lot of things for me. But you're going to have to spend some time studying, right? So for you, whether that's note cards, whether that's spending time on Google Images and Googling quadricep anatomy, Googling, posterior calf anatomy, Googling, chest anatomy, and really breaking down all those, because I'm a very visual person, and I imagine if you're getting into personal training and fitness, you're probably pretty visual as well. So that can be a helpful way for you. There's also some really beneficial apps that are out there too. You got to find your way of studying it, but you need to be able to break down and memorize and be able to pick out the major muscles of the body. And I'm not so stressed about like all the different muscles of the forearm, all the separate little muscles of the, the calf and the, leading down into our flexor digitorum longus. Like that can be really confusing. But understanding all 4 quadricep muscles, right? Vastus medialis, vastus intermedius, vastus lateralis, rectus femoris. You need to be able to understand those, right? Because certain small little changes in our movement and our angles, it starts to allow us to emphasize, small different areas of the muscle. And it also allows us to better understand like issues and injuries and other things that our clients have had. And if you want to be operating at that higher level as a trainer, anatomy is an important part for you. So there's my soapbox, but you definitely need to spend some time on here. Another one, you can probably Google anatomy chart with blank ones and filled in ones and use that as a way to study. Essentially everything you see on here for the most part, should be muscles that you should be able to recognize. Because then when you're going to come down to, understanding exercises and movements, it's great because then you can pretty much target any muscle group. It makes being the training side of things, it makes like the physical side of things so much easier if you just put the work in now for that, all right? But getting further into and breaking down muscle fibers, what makes up those muscle fibers, right? Because it really gets down to thousands and thousands of small little strands that all combine together to give us this strong structure, all right? So contains cellular components. Again, I'm not so concerned about the cellular side of the muscle fibers, but some important ones to keep in mind here too. Not only have inside the cellular plasma things like myoglobin, oxygen binding myoglobin. This is important especially for more of our slow twitch muscle fibers, more of that endurance capacity, because that's where red blood cells come into play. And also mitochondria, because this is the aerobic energy producers inside of the body. So these structures live inside of the actual muscle fibers and the cells themselves. Unlike typical cells, they have structures also called myofibrils, and this is going to be what we talk about with increasing muscular tension and the good old sliding filament theory. All right, but there's some contractile elements. So these myofibrils, I'm going to try to break down some complex topics for you guys very simply, and then we'll also cue you to some additional videos that are maybe even better at explaining and visualizing some of what's happening here. But within a myofilament, what we'll call, there's actin and myosin, right? So actin is referred to as the thin filament, and myosin is going to be this thicker filament. And they happen in these cross sections, these sections known as sarcomeres. So here's somewhat of a visualization for you guys too. And you can kind of see the thinner and the thicker filaments in the most simplistic way possible. When we're at rest and we don't have muscle contraction, there's a physical space between those two, right? And in order for us to have muscle contraction, not only do we have to have attachment, but then we have to have movement as well. So these structures, though, give us the ability for that. So if you think about that happening hundreds, if not thousands of times, multiple times as we go through something like a bicep curl, that crossover of those actin and myosin filaments, that's what allows a muscle to shorten, right? Because at rest, we only have a certain amount of crossover. As we have contraction, we cross over those actin and myosin filaments. This sliding filament theory that we're going to break down hundreds of times happens in order for us to have this contraction and then relaxation. So again, at rest, there's no physical connection between those two. When we have the right cellular environment, as well as things available, that's when we end up having muscle contraction, all right? But just from your general structure standpoint, I know right now, if you've never seen this before, you're probably like, Joe, I have no idea what you're talking about. But don't worry, you're gonna be able to spend some additional time searching and we'll break more down too. All right, in order for us to generate force, in order for me to have muscle contraction, it starts neurologically. So what has to happen? I have to send a signal from my brain through my nervous system to that actual muscle, which we're going to call, that's going to happen through our neurons to our alpha motor neuron. That's going to be the last neuron that we have activation of before it reaches the actual muscle fiber. So I have that signal that's sent. Then I have acetylcholine. This is going to be a neurotransmitter released into that space between the two. And then I have activation. Now again, I'm simplifying even a more complex process, but for our sake right now, we have to have a signal sent to that alpha motor neuron, and then we have activation or potentiation of the actual muscle fiber and cell itself. So then what happens is from there, my body releases calcium into the actual muscle cell. All right, now this is really important. We talked about actin and myosin not really being touching right now, right? There's not a physical connection. The release of calcium into that cell, it shifts some things to allow that connection to happen. Now, all right, cool. So that's where you can start to think like, okay, cool, like I understand. Calcium's important for the body. I always knew that, but I wasn't really sure why. Well, internally, it's important for muscle contraction. Otherwise, we can't have it appropriately. So when that happens, that allows us to have this sliding filament theory, this connection contraction that we have inside the body. Now we also have to have ATP inside the body. That's going to be the energy currency, adenosine triphosphate, which we'll go further into. But as long as I have energy available and calcium, I can have contraction. All right? And then when I want to have relaxation, we have this kind of semi-complex sodium-potassium pump that gets calcium back into the sarcoplasmic reticulum, and I have relaxation. All right? So again, this is like semesters of physiology that I spent trying to understand this, so I don't expect you to get it yet. We'll have more videos to break it down. But that's kind of your simplistic version from the motor unit contraction. You'll also see some stuff in the book that's going to explain this a little bit further for you as well, step by step. I'm not going to try to just go through and read those different pieces to you now. We talked about most of it. It might have happened a little fast, but it's definitely, the detail in which you're going to be tested over this is probably not the detail in which you're going to read right here, but it's an important process to understand, because I think understanding how muscle contraction happens neurologically and chemically in the body is really important, because things like sodium-potassium balance, like hydration levels, electrolytes, it all starts to make a little more sense because all that's interacting inside of the muscle cell. That's where we get things like cramps, tetany and contraction of that muscle. So that's really all these different slides are breaking down, is a little bit of the sliding filament theory. And now getting probably to something you might be a little bit more familiar with, which is like slow twitch versus fast twitch muscle fibers. So we spent a little bit of time trying to break down muscles themselves. What do they do? What's some of the muscular anatomy of a cell? We talked about sliding filament theory and contraction. And now muscle types, right? So we have slow twitch and we have fast twitch. All right, and for the most part, there's some emerging research that says you may be able to go from slow to fast or fast to slow, but for the most part, you have what you have at a certain point in time in your life. Meaning like as I'm an adult, I have a certain number of slow twitch fibers and a certain number of fast twitch fibers. Doesn't mean I can't get more explosive or become more of an endurance athlete, but I can just train those fibers a certain way. All right, so your slow twitch fibers, your type 1 muscle fibers, those are going to be higher in capillaries and mitochondria. That's great, right? Because for our aerobic energy system, blood flow, oxygen, all those things are really important. So if I have more capillaries, I can have more gas exchange, which is great for aerobic energy. Mitochondria, we already mentioned, those are the energy producers, especially aerobically inside of the muscle cells. So what happens if I'm slow twitch, if I'm training endurance-wise, I've been training for a 10K, a half marathon, whatever, my body's actually going to create not only more capillaries inside of my system, but it also may produce more mitochondria. And then also myoglobin, which this is going to be what allows us to actually transport oxygen in the body. So all those super important for type 1. Increased oxygen delivery, right? We're trying to get more oxygen to those working muscles so that we can continue to have that sustained contraction. They're going to be a little smaller in size. They're going to produce a little bit less force, but they're also slow to fatigue. So this is also good too, because a lot of our postural muscles, we want to be slow twitch fibers, or they are slow twitch, right? We need those postural muscles to be able to hold us up all day, to be able to keep us in the right positions. We don't want them to fatigue very easily, all right? So although we may not have the same force generation or force generating capacity, they're going to be less likely to fatigue. Long-term and slower contractions. Hey, like stabilization, right? So that's something to keep in mind with your stabilization type training, is we are going to be targeting more of those slow twitch, type 1 fibers. And then type 2, fast twitch muscle fibers, right? These are going to be explosive, bigger muscle groups. And again, everyone has a little bit of a genetic predominance, meaning you may have a little bit more type 1 or a little bit more type 2, and that may make you more apt to be a great sprinter or a great marathon runner. But we all have a small predominance there as well, right? So type 2, fast twitch, they're going to be lower in those capillaries, mitochondria, and myoglobin, which means like a little less oxygen delivery, which means they might fatigue faster, but they can generate more force. So there are certain muscles throughout most people's bodies that are going to have more, type 2 versus type 1, the ones that need to be faster and more explosive. And again, there's trainability here. Like if I train for more strength and power, then I can increase the capacity of those fast twitch. And vice versa, same thing with the slow twitch. If I train more endurance, I can have somewhat of a shift in training those muscle fibers. All right? So muscles as movers, just some other words for you guys to keep in mind. You're gonna see quite a bit. These are great ones for you to get right on an exam and also just understand how some of our muscles work together. We have agonists. These are gonna be like your prime movers. So in a squat, let's think like my glutes, my hamstrings, and my quadriceps. Those muscles are gonna be my prime movers of the movement. Synergistic muscles. These are muscles that assist the prime movers. So at any given point in a squat, you might have one of those three, the quads, the glutes, the hamstrings, that are predominantly moving the exercise, but the other muscles may be synergistically helping that movement to happen too. All right, and then and you guys have some examples here as well. And then stabilizers. So let's say something like I'm doing a chest press or a push-up or throwing something. You know, I have the muscles of the rotator cuff that are small, more postural muscles. They're not driving the movement, but they're helping to stabilize that joint during the exercise, or during the movement, whatever it is. None of those muscles in the human body are going to work by themselves. They all work in concert with others or against others. So keeping that in mind as you're thinking about exercises, what ones primarily move the exercise, what ones are kind of assisting in what's happening, and what ones are stabilizing the rest of my body. And here's just an example for you guys. We already talked about a couple movements, but you guys think about it. In a push-up, all right, in a push-up, what are the prime movers in that push-up? All right, and we'll think about it specifically because we could start to argue as we'll understand biomechanics that different angles are going to, bring in different muscle groups, especially when it comes to something like a push-up. But with our girl's hand position here, right now, a little bit out wider, right? So from here, we're going to get a decent amount of joint action. And if we're looking at it like this, we're going to get a decent amount of joint action like this in the shoulder if we're looking at that push-up, right? So we're going to call that, we've got this horizontal AB and AD duction happening in the shoulder, all right? So we'll have from there, what muscle primarily causes that in the shoulder? All right, so we're going to get a little bit of anterior deltoid, and we're also going to get quite a bit of pectoralis, right? So in that position where she's out a little bit wider, the pecs have a great angle to pull the arm across. So we could argue and say, you know what, the prime mover of that exercise, the way she's positioned, really is going to be the pectoralis major, our pecs, all right, chest muscles. But on top of that, our synergistic muscles, because we also, in this position here, I do have a little bit of anterior or a decent amount of anterior deltoid that also helps to cause that motion, all right? Especially since my elbows come back a little bit. Now I also have a little bit of flexion in the shoulder. So anterior deltoid is going to be maybe a synergistic muscle. And we also know as I go from having bent to straight arms, I've got to extend the elbow. So I'm definitely probably also going to be getting a little bit of tricep activation. So I would say, you know what, prime mover is probably going to be the pectoralis major in the position that she's in, but I'm also going to have some synergistic activity from my anterior deltoids as well as my triceps to play in there. And you might start to think too, well, what about my stabilizer muscles? What's stabilizing to hold me here? Well, the cool thing about push-ups is it starts to really get to be full body, right? I've got a lot of core activation. I've got, even some hip flexor activation to hold me in that position. But even more specifically, if I'm talking about the upper extremities, we're definitely going to have some stabilization happening in throughout that rotator cuff that we talked about already. So there's a lot happening in a push-up. But for the most part, that's a good example of all the things that are going on and how we can break down some of the different roles of those muscles in the body, all right? And then getting into, we talked about some of our three main systems, our neurological system, neuromuscular system, the muscular system, and our skeletal system. And like I said, we could spend a lot of time trying to break down the endocrine system because it's extremely complicated. And hormones really are the master regulators of all things like metabolism. But for the scope of the course, we're just going to talk about a couple things, all right? So the endocrine system is a system of glands that secrete hormones to control bodily function. So what happens is you have a couple of main organs that secrete hormones into the bloodstream, and then based upon what those hormones are supposed to do, you have different receptor sites throughout the body. And based on those certain areas, those receptor sites will utilize the hormones that might be free floating in that blood, all right? So it consists of host organs, chemical messengers, target cells, and these bind to those different areas of the body, right? So our most important here, we're going to have this hypothalamus, the pituitary gland, and the pineal gland, all right? Obviously the thyroid, you guys may have heard of the thyroid gland, especially when it comes to maintaining metabolism, and that's definitely valuable. You're going to have individuals that you may run into. I know I've had quite a few clients in my 12 years of training that have had things like hyper or hypothyroidism, and that's definitely going to have a potential impact on their weight gain and weight loss. So just a general understanding is going to be very valuable when it comes to those things, working with different types of clients. And especially as we understand clients that get into their 40s, 50s, and 60s, whether they're male or female, there's definitely a lot of hormonal changes happening. As men, generally, not everybody, but generally we'll have some decreases in things like testosterone and growth hormone as we age. So some of that can definitely impact metabolism, ability to maintain and gain muscle. And then women that are going through, menopause, all kinds of things are happening with estrogen levels. And again, that could be another one from a client standpoint, a frustrating area to be, where it seems like everything that we're doing right on the training floor, they're doing well on the nutrition side, and things just aren't moving like they should. And that maybe you may have something going on hormonally. So what I can say anecdotally as well is that it's very beneficial to develop some good relationships with just doctors in general too, and encouraging your clients to go out and get blood tests on a yearly basis. Because although it is very easy these days to get things like hormone replacement therapy, and one could argue, does everyone need that? One could argue that some may really benefit from understanding those levels, but you only really know if you're tracking over time. One test isn't going to tell you exactly what's going on based upon where you exist. So either way, hormones definitely super strong in the human body. All right, so this breaks down a little bit talking about pituitary gland, the anterior, intermediate, and posterior. I'm not even really going to break into it, not because it's not important, but likelihood of this being part of your exam, very low, and also it just really starts to get us down a more complicated path. So we're going to skip that for right now. We talked a little bit about the thyroid gland regulating metabolism, and that is really important. We also have the adrenal glands that regulate fight or flight hormones, like we talked about before, epinephrine, norepinephrine. When we get into that fight or flight response in the the nervous system, we talked about some of that, the somatic versus the autonomic, and how our body responds. And then testes and adrenal glands, all right? So some interesting things on here. So these help produce testosterone. So one interesting thing to keep in mind, and especially as we talk about with our female clients, the lack of desire to bulk up. The ability to build muscle is generally much stronger in many men than it is women. Most men are going to have around 10 times the amount of testosterone as women. Doesn't mean women can't build muscle. They definitely can. But that's where we get into that conversation about strength training doesn't necessarily mean bulking up. But they do have a lot of adaptations that happen here. And the interesting thing is from a hormonal standpoint, this is all about blood glucose control. We already talked about in chapter 1 a little bit about diabetes and insulin, but insulin is a super powerful hormone. That insulin-glucagon interplay controls a lot of things, whether we're getting into more of an anabolic or a catabolic state, whether we're building up tissues or we're breaking them down. So we talked about that with insulin, definitely a really important one, and how exercise is a great way to help increase that insulin sensitivity from that single bout of exercise. All right, we talked a little bit about this as well, the effects of exercise. But I think from a hormonal standpoint, that's one where definitely keeping in mind that exercise is a stressor, and prolonged and consistent elevated levels of stress hormones like cortisol can have a long-term impact. It's not inherently bad. Cortisol has a role in the body, but all those hormones, they definitely do master regulate what's going on inside of the human body. So basic exercise science, chapter 2 of the NASM material in the Axiom Fitness Academy. I know we just threw a lot at you guys, another thick, dense, long one, but the nice thing is the course generally is very much front-loaded, and a lot of the information that we're trying to give you, and then what we're going to start to do is we're going to continue to start to try to tie a lot of it back together, tie a lot of things back into the different stages of the OPT model, and understanding, okay, cool, I've seen this a number of times, I've been hearing the similar terms, and now I'm understanding how the Golgi tendon organs and the muscle spindles play into my movement assessments and stabilization training in level 1. So, continue to try to start to just take all this in, spend time, going back through it and really solidifying some of the main things, your main takeaways here being understanding that human movement system and how our neurological system, our muscular system, and our skeletal system all have to be working in sync in order for us to get fluid movement. So much more to come. I appreciate your guys' attention. As always, hit us with some questions and get to studying.